Alex can come in.
Okay, let's wait for another minute or so. Start at 9:02, 9:03.
Will Michael join?
I'm not sure.
Okay.
I don't think so. All right, let's start. Hey everyone, welcome to the Harvard community meeting. So the agenda for today is one of our maintainers, Steven So will take you through the progress on the Harvard operator and have a demo of the end-to-end workflow. So deploying it with the operator, setting it up. All right, Steven, take it away.
Okay, thank you, Alex. Let me share my screen. Okay, can you see my slide? Okay, cool. Let's start it. Yeah, thank you everyone for joining this session. I'd like to introduce some, milestone of Harvard class operator development work. Here is today's agenda. First, I will quickly go through, give you a quick introduction about the background and some knowledge about Harvard operator, Harvard class operator, and then I'd like to share the roadmap of class operator and the overall Harvard operators, and then I'd like to introduce the operator work group. They are working on the Harvard class operator development work, and the last part is a lab demo. Okay, here's some background of the Harvard operator. So first, we have so far currently the status is we have a Harvard operator. We call it a Harvard corporate. It's under the GoHarbor dash operator repository. This operator is contributed by the OVH Cloud team. Current version is 0.5.1. This operator is focused on deploying the Harbor components. It does not include the dependent service like a database cache and storage. So here is a very simple diagram. In the Harbor operator, there will be a Harbor customer resource, Harbor CR, and this CR will manage the core portal job service notary and some other Harbor component service, and it not only include the required Harbor components, it also include the optional component. Yeah, you can decide to if you want to install the notary Claire or charter museum. It's keep the similar experience as the offline installer or the installer experience. Okay, based on this, we'd like to we hear some ways from the community. Yes, they want to operator to deploy high availability and stability. They want a Harbor deployment with high availability and stability. So based on the Harbor operator, we start to to develop a cluster bridge. So far, the code is under the Go Harbor / Harbor - cluster - operator repository. It's covered by the operator work group. So far, its version is 0.5.0. This operator is built based on the core operator and not only cover the Harbor components, it will also include, cover all the dependent service of the Harbor component service, like the post seeker database, the Redis cache, and the storage. Here is the overall architecture of the cluster operator. So from this diagram, we can see the overall, structure of the cluster operator. At the top level, there will define a Harbor cluster, customer resource. It will be covered by the Harbor cluster controller, and it will manage the over all of the, all of the service, for running the Harbor registry, include the Harbor component service as well as the dependent service. So the Harbor cluster customer resource will own the Harbor customer resource as well as the post seeker and the Redis and the storage. This storage is covered by the MEL. The storage they are okay. For handling such dependent service, we leverage the existing kinds of operators. For example, for the PostSeeker, we use the PostSeeker operator. So here we have a PostSeeker controller, Redis controller, and MEL to cover to handle all the dependent service. Okay, and use the core operator. We use the core operator to handle the Harbor customer resource. In the Harbor customer resource, it will cover the ingress service and kinds of ports to run the Harbor registry. Okay, and I think the overall workflow is where the Harbor cluster controller will call the related dependent service to create the dependent service and inject the related information into the Harbor customer resource to start the Harbor registry. So that's the overall flow. It's simple. We start post seeker, we start Redis, we start storage, and then we inject the related information to the Harbor CR. Then we start the Harbor. Okay, so the overall Harbor will start to work. So this is the overall architecture of the cluster operator. So we have define a customer resource, the CRD, to describe the Harbor cluster CR. We can quickly go through the related spec. This spec can be found in the repository. It's very simple. We cut off, most of the unnecessary property. We only expose the necessary, the required field to the user to configure the cluster. I think most of the part is keep same with the Harbor CRD. Yeah, that's provided in the Harbor operator. So like you can define a version. This version is used to determine which image we will use for start the Harbor service, and the public URL defines the access point of the Harbor registry. You can define admin. You can create a admin password for your admin account and define a certificate issue to generate a related certificate. So far, we use the cert manager to cover the related certificate management, and you can define how many replicas you want to how many copies you want to run the service. Okay, this is a global replicator. Actually, we leave flexibility for the job service. You can define special replicator for job service because job service maybe need more resource to run the job. So you can define a different replicator, maybe more larger than the global replicator. Okay, and here is some the comment part is for some optional component service, like you can define the clear. So far we don't support the traffic yet. The charter museum and the notary. Okay. After that, you need to define the related dependent service. The first one is the cache. We use the Redis as a cache. You can define external Redis because, for example, you already have a Redis service or some cloud Redis service. Then you can directly use define the kind as a external and create a secret to point to your external Redis. Yeah, if you want to in cluster Redis, you can define it as a in cluster here. Then you need to just define some resource requirement and the storage class and the storage size. Then we'll use the Redis operator to create the Redis service for this harbor. Okay, I think it's the similar case to the database and the storage. You can use external database if you want, and of course you can use in-cluster database. Then we'll create a high availability PostgreSQL for your harbor. The storage is totally the same. You can use some external, for example, S3, Swift, all the storage driver that supported by the registry. Of course, you can use in-cluster operator, in-cluster storage. This in-cluster storage is supported by the MiIO storage. Okay, in this you just need to define some resource requirement. So this is the overall cluster spec we are defined for the harbor cluster customer resource. Okay, after the quick introduction of the current operator, I'd like to share some roadmap of the operator. So far, for the harbor operator, they only cover the harbor version 1.10. Actually, we have published the 2.0. Maybe the 2.1 will publish soon. So the OVH team is already started to work on the operator version 1.0. This version will target the harbor version 2.x, and they also refactor the CRD architecture and do lots of improvements. So far, we only have one CR, and one CR, and the component are driven by the Kubernetes native resource. So in the 1.0, for each component they will have their own CRs, okay? And those CR have their own reconcile process, and those CR were owned by the harbor CR, okay? So after the operator is done, the class operator will do we also do refactor to to rebase on the new operator version 1.0 to support the harbor version 2.x later. Okay. And so far they have two different code-based repository. I think after the 1.0 release, maybe we are consider to start to merge the code base of the operator, as a unified repository in future. Okay, I'd like we have started the work for several months. I think most of the people have contributed a lot. They are community contributors. They actually this is their part time. So I'd like to to say thank you very much for everyone for the outstanding, contributions. They are, Herman Zhu from Yunmama, and Canfeng Wang from NetEase, and Xiaoyang Zhu from QingCloud. And we also have, Ziming Zhang from VMware and Wei Wei from VMware.
And
Okay,
two guys
before
from OVH, right? Give a shout out to Pierre and from OVH.
Here I just share the contribution of the cluster operator. Yeah.
Got it.
Okay, before the live demo, I do want to clarify some no issue. So far, because the operator is targeting the Harbor version 1.10. In this Harbor version, Harbor does not support the Redis Sentinel mode, so we need to set the Redis replicator as the only one to avoid such a problem. Okay, and for the status Harbor CR, there is it's not correctly set. So in the service status for the Harbor CR status, it will always be unknown. So we'll check it later. So that's a two known issue. Okay, about the demo. First, it's only on the Kubernetes cluster. So I use the Kubernetes cluster. It's created by and managed by the VMware Tanzu Mission Control. This is our production, Kubernetes management and platform, SaaS-based platform. I have created my Kubernetes cluster on this platform. This cluster have 32 core and 126 GB memory, and one control node with plus 3 work nodes. For the overall demo flow, there has some precondition. First, we need to deploy a certain manager because we use the certain manager to manage the certificates. So we need to deploy certain manager to this cluster, and we also need we use the ingress controller to expose the accessible service. So we need to deploy an NGX ingress controller to the cluster, and we enable the load balancer mode for the ingress controller. After that, we can deploy the operators. We provide a customization template, so we can use one-click command to deploy all the related operators. After the operators are ready, we can start to deploy Harbor. I have dropped deployment manifest YAML. Here we have set the domain as harbor.goharbor.io, and the notary access endpoint is notary-harbor.goharbor.io. I will set the replicate equal to 3, including all the Harbor components like including the optional like Claire, Notary, and the Charter Museum, and all the dependent service will enable in cluster mode. That means I do not need to provide any external service, or they are all created in the cluster. And then we'll try our Harbor to doc push, pull, scan, replication. So the related scenario. So this is demo flow. Okay, let's to see the demo. Before starting, let's see what we have. This is my Kubernetes cluster. Can you see my browser? Okay, so this is my Kubernetes cluster. Okay, you can see some resource contribution and some metadata on my cluster. And so far, actually, I have deployed. Actually, I have deployed the certain manager. So I will not repeat the work. So here I have a certain manager running. And I also have an ingress, NGX ingress controller running here. Everything is okay, it's healthy. And actually the related operator has been deployed before, so I will override the operators. Let's back to the terminal. Can you see my terminal? Okay, so I have mentioned in my slides. Actually, we have a customization. I use customization build to generate all-in-one YAML file. Actually, this is all-in-one is used to deploy all the required operators. We can have a check. So different create namespace and install CRD and create cluster role binding and create the operator deployment. So everything is in this all-in-one YAML. So for install the operator, it's very easy. You just use your kubectl. Oh, sorry. Amplify. Apply use this all-in-one manifest to deploy all the things required. Yeah, because I have deployed the operator before, so everything is just to check if they need to do some changes. I think everything is okay. So let's back to the management portal. We can say, for example, in the Harbor cluster operator system, here the Harbor cluster operator is running well. And back to, I deploy the different operator into different namespace. Here is the Harbor core operator. It's running very well. And we can say Redis, psecure, meow, everything is okay. So that means, yeah, we have the capability to deploy a Harbor. And I can show you some. Because there's CRD. Let's see, CRD Harbor. This is a Harbor CR. This is Harbor cluster CR. Yeah, this two CR had been registered to the Kubernetes cluster. Okay, so next we can start to deploy the Harbor. One Harbor. I'll use this manifest. I'll create a Harbor namespace and create an administrator secret for my admin account. And I use a third issuer to issue my certificate. And this is not native. That's okay. And for my Harbor cluster, I'll use Redis in class. So far, because we have no issues, the replicator should be set to 1. And also set the public URL to harbor.goharbor.io, set the notary to notary-harbor.goharbor.io, set the replicator to 3, and let's and enable charter museum, and enable Claire, and create storage. This is use MEL, and point the Harbor version to 1.10.0. Okay, so this is all the spec. Let's deploy our Harbor. Just apply. It may need a while to make it ready. You can see the cluster is created. Let's get in the Harbor namespace. So you can see there is a Harbor cluster, they are created, version is blah, 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 public, URL, blah, blah, blah. Actually, if you want to use append -o, option, is white. You can see more information. You can see the cache, if the cache service is ready, if the database is ready, if the storage is ready, and if the Harbor CR is ready. So far, no one is ready. Actually, we can back to the portal for easy to check. Here is a new namespace, Harbor. New Harbor is deployed into this namespace. Okay, I think the related service has been created. I think they are doing initially. It's this one is okay. Let's refresh. Okay, you can see everything is out. The related Harbor component. Let's back to the terminal to see what we have. Okay, you can see the related service is ready. Actually, the service has been ready, but this is it's a known issue, so it's not it cannot be changed to be ready. And we can check the resource. Sorry. Okay, you can see pods, all the pods are running here. This is all the pod. This is all the Harbor component. And sorry, the deployment, they are replicated all three. And the service include the MIO. And this is for the, I think it's for Redis. This one is for maybe for the processor. So everything is here. I think now it's time to access the Harbor. Let's first see the portal. If we can open the portal. So we use the harbor.goharbor.io as our access point. Let's see. Okay, portal is up. Let's log in. Okay, coming in, and we can try create a replication first. We need some artifacts. We create a Docker. Yeah.
Docker Hub may have problem. So too many requests.
I just use one. I think it's okay. Pull from hub. Pull based. Use my rich endpoint. Okay. Let's pull the Redis library. Redis and several different tags put into the library. Okay, it started to pull. Let's back to the terminal to get the certificate and try the Docker pull push. Give me 1 minute. Oh. Cool. Sorry, give me 1 minute. Decode. I think it's I copied, have unrecognized character. Let's use this one. Data third. Yeah, first we need to export the search. And move this search to the TC dog. Okay, I forgot. I also needed to put it to the notary. Notary. This is the notary access point. I'll also put this. And at the same time, I need another certificate for the notary certificate, because we use different certificate to send the ingress. Okay, move. Docker, yes, notary, Hopper. Okay, let's see if we have set the notary. Let's directly enable the notary. I forgot. I think it's right. This is another. I needed to change it to my notary. Okay, let's send an image to push. I think it's, sorry, it's Harbor. I push this one. Docker push TV. It's pushing. I think it's some. Oh, sorry. I know what happened. I override the certificate. Let's give me 1 minute to okay. Change the name and move this to Docker, yes, notary, Hopper. Okay, let's push again. I'll go start to send the image. Let's give me a command as or secret. Okay, it's a successful push and send. Let's back to the portal. Okay, the replication is done. Let's see what we have now. Yeah, we have two repository. One is that push. It's a send. You can say it's send, and this one is I pull from the Docker. Let's scan. it started. I'm not sure if the database is ready. Maybe not all ready, but I think Claire has some data to do the scanning. Okay, you can say we have scanning, and let's delete. Okay, one, delete one more. Because I delete two tags, so let's TC. Okay, it's finished. I think because there are some, data reading issue, so it's very slow to read. It will be back later. Let me see. I think it's okay. The replication log has. It's not ready. It's very slow. We'll check it later. I think the log will be back. So I think all the function are, does work well. So you can use one command to deploy your Harbor cluster with HA mode. So it's very simple and stable. And you can, sorry. You can get your, workable Harbor registry service when you want. And actually, in this cluster, I have deployed two Harbor. You can say, let's through the portal to say, the first one is a Harbor. I deploy the, today a new Harbor registry into the Harbor namespace. Actually, here is a sample. This is also a HA Harbor. Actually, in my cluster, there are around two Harbor registries are running, and this one is also can be accessed. Yeah, this is a sample Harbor. Okay, you can see in my cluster I have two Harbor. So you can deploy actually based on your resource, of course. You can deploy any number of Harbor registry in your Kubernetes cluster, and it's very easy. Just define a Harbor cluster spec, use kube. Okay, everything is up. So that's all the demo scenario. Any questions?
Hey, thanks for the demo. I have a question. Do we have any instructions on how to deploy this on a kind cluster?
Yeah, actually, the first training we are trying on the Kend. Yeah, you can deploy Kend. Actually, I have tried deploying in the Kend cluster, and I dropped a document. It's under the cluster operator repository. In the docs folder, there is the installation local. So this is targeted for Kend cluster. You can follow this one to deploy Harbor to your Kend cluster. But this doc is late to out of date because it does not use the key customization template to deploy operator. It uses the the original deploy way. For example, for the Harbor cluster operator and the Harbor operator, they use from the source code, and for others they can refer different GitHub resource to deploy the operator. But yeah, that's okay. You can deploy Harbor to your Kend cluster, and we will update the document later.
Very cool. Thanks.
Hey, I have a few questions. You use Cert Manager to sign the cert, so Cert Manager is a must-have, right?
Yeah.
Okay.
So far, yeah, it is. Actually, we are considering if future we can use more flexible, but I think Cert Manager can use your root CA to send its certificate, so you do not need to.
Yeah. And in your demo, you use two CA for one for Harbor and one for Notary, but I think they are signed by one root CA, right?
Yeah, I think that's actually I have to do some research on that part. I think it's the limitation of Cert Manager because the Cert Manager controller will identify the ingress and generate the certificate. So it seems it's a little hard for Cert Manager to generate a CA to cover multiple domains. So that's the current limitation.
Okay.
I think
okay.
yeah, we will have talk with us. Maybe in future we can, if we have only one, only one ingress, that means use on one domain. So that's this purpose will be gone. For the notary, for the core, for the V2, they are use the one domain, but different subparts.
I think we can talk with Wei offline, but I think the Cert Manager should only have one root CA. You think the enterprise scenario, right? No, I only need one root CA to sign all the cert.
Yeah, possibly. So maybe I not learn more about the Cert Manager. Maybe because I think Cert Manager, because currently we use the self-send, so that's maybe the cause of the limitation occur. So maybe use others issuer. You can use one root CA to send the certificate. That maybe we can resolve the multiple CA problem.
Yeah. And as for the database and the Redis operator, are we reusing the community maintained operators?
Yeah.
So are they actively maintained?
I think so far it's active because
okay.
there are some commit coming into their repository maybe 10 or 20 days ago. So I think it's active.
So that means if you want to change some setting of the database, we need to, write a PR to the upstream operator, right? Or does it expose a lot of settings?
You mean what you want to, for example, you found some issues from some operator and you want to submit a PR and maybe they are open to accept such PRs.
Yeah.
So frankly speaking, I've not tried yet, so I don't know. So far, I think the operator is okay for our scenario.
For example, the database, it has to be strong consistency. And I know in Postgres, there is some tricky setting. You must set that so that Postgres is strong consistent. We need strong consistency.
Possible, but they expose lots of configuration. Okay. So maybe you don't need to change the core. You just adjust your configuration.
Okay, so you hide these settings in the Harbor cluster.
Yeah, we hide some configuration.
Yeah, and by the way, if you want to set external database or Redis, how does the secret should look like? I mean, how does it look like?
We have, I just mentioned in the spec here. I think at last we need to write a document. So far, just a comment in the spec MD file. For example, let's say database. Here, you need to create a secret about contain something. Let's say.
And as for the replica setting, there is a global replica setting and one replica for job service. Is that due to the limitation of the OVH operator, or it just, you know, your opinion that we wanna expose?
Yeah,
plan.
our consideration of design such spec, we want to keep the spec as simple as possible, right?
Okay.
I know the different user may have different requirements. That's it's our start point. So far, we want to this is the only required subset of the configuration. So I think the job set, because they need more CPU or memory, so they can increase separated respectively to
so that
more
means,
large replica.
So that means I can set it in the OVH harbor core operator. You just decide to hide it, right?
Yeah.
Okay. Yeah. No further question. Really great. Thanks. I'm gonna have a try. Here.
Okay. No more question?
Yeah. So do I have to use min.io? Can I use something else?
Yeah, you can use that for it.
I said, do I have to use min.io? Can I? How do I set something else?
Yeah. So far, for the HA storage, min.io is a very it's a good choice because it's SDN compatible, that's supported by the registry driver, and but if there's if without min.io, I'm not sure if there are other choice to support the in-class storage, but you can at least you can use external.
Yeah.
I think the worst case is you can deploy min.io tenant, HA tenant, and point to the Harbor cluster spec as an external storage service. But that's not the original design purpose of such class operator. So we want to provide some all-in-one experience for deploying your Harbor.
By the way, have you tried to run our nightly test suite against the?
Not yet. I want to clarify. This is I think it's a preview version. Even we release the 0.5, I think it's a preview version because we don't want to do more work on this version because we have a newer version like 2.0, 2.1. So we want to put some effort to work on the new version. So,
absolutely.
Yeah. But of course, the new version will based on the current work.
Actually, I do have some concern regarding the performance because when you have multiple storage nodes and they do replica, for example, the database, and we want strong consistency. So
maybe
transaction will be.
I understand your concern. Maybe we need to find a way to to write some testing to test the case if the cluster operator can match the case.
Yeah, I think we can run the current skill and performance testing against the operator deployment.
Okay. Logger is out. I'm not sure why it's so slow.
Steven Joe, I think this is really great. This is one feature we have looking for like more than 1 year for the HA capability. Now,
yeah, anyway, I think it's a good start, right? It's a good start to do further work. Okay. If there is no other question, okay, I'll hand over to Alex.
Sorry. I have a quick question regarding the garbage collection. So yeah, we're actually running Harbor 1.10.4, and we are planning to migrate to 2.1 directly. So because of the garbage collection which we need to run, which actually involves the registry to be in the read-only mode. So So from 1.10.4, can we directly jump to 2.1?
Yes.
Ah, okay.
Yeah,
Then
so it's
one
usually
follow-up question. Oh, sorry. Go ahead.
I was gonna say it's usually -2 minor releases. So on a 2.1, you can go from 2.0 and 1.10. And then from
Okay,
2.2, you can go from 2.1 and 2.0.
great.
So
When is the release planned? Is there any release yet? Because we saw that there's the tech demo out. Is there any date
there is
on the roadmap?
a tech preview release on GitHub right now. They can test out. That already has the garbage collection, non-blocking garbage collection.
Yeah,
the
I know,
GA
but
goes
I'm
out.
talking about the final release.
So if
Next week.
there's if
Next
there's
week.
no
Oh, okay.
further issues found, we will release next week.
Hopefully.
At least we will. I think if there any issue we found, but I think we can release in the second week of September.
Okay, awesome. Thanks.
Yeah, I think if you have some, because internally we have testing, we have created a very large storage of images to do the GC. So far, we haven't found any issue. But given that you are interested, if you have any staging or developing environment you want to try and preview build, we can also share the build to you, and you probably also can do some tests before our GA time.
Yeah, especially if you have any idea to improve it, we may still implement it before.
Yeah, we can still deploy the tech demo or the tech release before, of course, promoting it to production. But we were just wondering about the general time frame because of course the garbage collection as a blocking factor on production is not great.
Yeah, I think if you can take the new build and do some application images to the 2.1 build and run GC based on daily work, that will be really helpful for us. So the scenario we have created might not have that large number of storage as you have, right? So yeah, if you can do that, really helpful.
Yeah, thank you so much. Thanks for the feedback.
I put the link in chat in case you wanted to check it out. So that's the tech preview.
Cool, thanks.
Yeah, sorry, but I have one more question regarding the image tags listing. So right now we are using GCS as the backend storage. So whenever we actually try to view the tags, if at all, if there are like too many, then it takes quite a lot of time for loading it. So is it something which we are doing in the configuration side, which is a mistake, or is it already noticed as an issue in Harbor side itself?
It's fixed in V2. But if you have many images, the migration may take a while, because in V2 we store all this information in Harvard's database. In V1, some of the data is still in the storage, so we need to call registry API to get the info. That's why the listing is slow, because it need to call a lot of the storage API to get this info. In V2, it's much better in this particular case. But that said, in the migration, when Harbor start up, it will walk through all your images and try to extract the data and insert the records into database. So that may take a relatively long time. Just be prepared. And if you are using, especially if you are deploying Harbor on Kubernetes, you need to set the, you need to adjust the setting of your prob of the Harbor core pod. Otherwise, it is possible, because it's possible the core is irresponsive for a long time and Kubernetes will kill it. But in fact, the core is working. Does that make sense?
Okay.
Yeah.
That's a very good hint. Thank you so much.
Thank you.
All right. Any other questions or comments? I think we can end here if no more questions. Thanks, everyone.
Yeah, thanks for taking the time.
Thanks. Bye.
Thank you.
Thank you, Alex. Thank you all. Bye. Thank you, Steve.